To titrate your samples, you will treat each sample individually, titrating it all the way through to the end point before beginning the next sample. The titration procedure begins with your weighed out sample, dissolving that sample in approximately 75 to 100 milliliters of deionized water. You can use the markings on the Erlenmeyer flask, or you can use a graduated cylinder to measure those volumes. The exact volume of water is not critical because the moles of chloride are known based on the mass. You then want to make sure that all of the sample dissolves. Okay, do not stick a stirring rod or anything inside of the sample so as not to lose any chloride. And before beginning the titration, make sure that you have no more crystals apparent. To the dissolved sample, you're going to then add approximately 1/10 of a gram of dextrin. This is to make the endpoint more visible, more sharp. So adding the dextrin and then swirling that to dissolve it. Sometimes all the dextrin does not go into solution. As long as there's dextrin there to maintain silver chloride as a colloid, you'll be fine. Okay, after adding the 1/10 of a gram of dextrin, you're then going to add 5 drops of the dichlorofluorescein indicator. This indicator is light sensitive, so you don't want to add the indicator until just before you're ready to titrate. Adding the indicator at the initial stages of the titration imparts a fluorescent yellow-green color to the solution. Initially begin the titration by rapidly adding titrant. Swirling constantly throughout the solution. Throughout the titration, swirl constantly. You'll begin to notice that the solution takes on a more cloudy tint as more silver chloride is produced. When the solution becomes sufficiently cloudy, and you'll notice the pink kind of disperse more over the top, you want to slow down your delivery of titrant, more kind of a drop, drop, drop type of pace. And then this will fade through a milky yellow to a more of a milky peach color. When it reaches the peach color, you'll notice it looks like the pink is going to disperse and perhaps stay in the solution. You'll notice the pink almost wanting to stay, and the solution itself might have kind of a peachish, orangish color tint to it. This is the point where you want to add single drops at a time. If you have any droplets that cling to the tip of the burette, you can add those to solution by touching the sidewall of the flask to the burette tip. And if you think you might have the correct endpoint, you want to make note of the volume and add another drop or so of titrant. Upon adding this next drop, you notice that the solution color is still changing, so you haven't reached the end point yet. So if you think you may have it again, you could document this volume, add the next drop. The solution color is still changing. You wanna, when you reach the end point, you'll reach a point where the next drop of titrant doesn't change the color any further. This took on another color change. Okay, this little partial drop that's hanging here, if I touch that to the sidewall of the flask, the color is not changing. So the volume that was recorded prior to adding that extra drop is the endpoint volume. when you have a kind of a strawberry pink color in your solution. Be sure to record your final burette volumes to the proper accuracy for a burette. The burette is calibrated to the nearest tenth of a milliliter, which means it can be estimated to the hundredths place. Due to the subdivisions between the tenths place being so small, it's easier to humanly estimate to the nearest 200th of a milliliter. So you'll notice on this particular burette that the bottom of the meniscus red at eye level is just before the 40.1 mark. So with that bottom of that meniscus being just before that mark, I would record this volume as 40.08 milliliters.